All right, great. So now that we know a little bit more about Chainlink and Chainlink VRF, let's begin to use it. For those of you who are looking to get a good feel, definitely be sure to go through the documentation, scroll down to get a random number, and even scroll down to this button, Open in Remix, where you can actually try this code out yourself in Remix. You get a little pop-up that looks like this with all this code already in here for you to work with. It's defaulted to using the Sepolia chain. So if you want to try this out in Sepolia, feel free to do so. Now you'll notice in the docs, there's a couple different ways to do it and a couple different steps. So there's two main methods, subscription and direct funding. Direct funding is when you send link to the contract that's going to be calling the random number. And subscription is when you have a separate contract that you load up with link that your contract will pull from. We're going to be learning the subscription method because it's a much more scalable model in my opinion. However, doing this requires a few extra steps, like setting up a subscription, for example. We're going to learn both the ways to do it through the user interface and how we can just do it completely programmatically so that we never have to go to a website. Remember, we want to work incredibly hard to be incredibly lazy. So let's go ahead and let's add this randomization. Now remember, getting a random number is actually a 2-transaction function, unlike most of what we've been doing, which are atomic, right? Everything that we've been doing so far all happens in the same transaction. Chainlink VRF is 2 transactions. One is to request the RNG, and then the second transaction is actually get the random number. So pick winner is really just going to be us requesting the winner, and then picking the actual winner will be in the what's called the callback function, or the transaction that the Chainlink node sends back to us. So we're going to send a request, and the Chainlink node is going to give us the random number, and we're going to use that instead. So what we want to do is we're going to go ahead and use the documentation here. We're going to scroll all the way down this get a random number section, and we're going to use this code to actually get the random number. The actual function call we're going to be doing is this right here. Request ID equals coordinator.request random words, blah, blah, blah. And actually, I'm just going to go ahead and copy that and paste that into my code here. And we're going to get a whole bunch of red lines, which is fine because we're about to update everything. So to make this call, we're going to first need a coordinator address. This is the Chainlink VRF coordinator address to actually make the request to. On every chain where Chainlink VRF exists, there's an address that allows you to make a request to a Chainlink node. This key hash is going to be your gas lane. If you don't want to spend too much gas, you can actually specify you don't want to spend too much gas. Your subscription ID is going to be the ID that you've funded with Link in order to make these requests. Request confirmations is the number of block confirmations for your random number to be considered good. We have a callback gas limit as well, again, to make sure we don't overspend on this call. And then we have number of words, or more simply, number of random numbers. And then we get returned a request ID. So this request ID is going to be a uint256. So we can do uint256 request ID. The coordinator is going to be the VRF coordinator address, which is different chain to chain. And since the address is going to be different chain to chain, we probably should pass this in through the constructor and make it an immutable variable. So right up in our constructor, we're going to add a new variable in here. We're going to add an address, VRF coordinator, and we're going to make this an immutable variable as well. So I'm just going to stick all my immutable variables together here. So we're going to do an address private able I underscore VRF coordinator. And in here, we're going to VRF coordinator equals VRF coordinator. And instead of coordinator, we're going to do I underscore VRF coordinator. So this VRF coordinator has this function request random words. And if we actually go to GitHub Chainlink, we can actually scroll through everything in here to actually find this. So we go to contracts, RC, v0.8, scroll down to VRF, VRF coordinator v2, and we do a little find in here. We can see that there's this request random words function that we're calling, right? So we're calling this external contract request random words. Now, to work with this, we're going to need a key hash, a subscription ID, number of confirmations, callback gas limit, and number of words. Some of these we can actually just grab from the documentation. I'm going to scroll down to supported networks. We're going to scroll down here. So there's the ETH mainnet ones here. If we scroll lower, Sepolia has some different ones, right? We have this key hash, some gas limit stuff, some premiums and stuff. So this key hash is going to be also dependent on the chain. So since the key hash is also going to be dependent on the chain, we're going to go ahead and put this into our constructor as well. So the key hash is a bytes 32 key hash, but I actually prefer to call it the gas lane because I feel like that's more accurate of what it is. So we're going to have this gas lane parameter, and this is also not going to change. So we're going to do I_gas lane equals gas lane. Let's create a new private immutable, but this is going to be a bytes 32 I_gas lane. And now that we have this, we can scroll back down. Instead of key hash, we'll do the gas lane. The subscription ID is going to be our specific subscription to the Chainlink VRF. So this, again, is going to be something that we're going to get from our constructor. So we'll do a little comma. This is actually a uint64 subscription ID. And we'll make this an immutable as well. So we'll say I_subscription ID equals subscription ID. So we'll copy paste this. This is a uint64 I_subscription ID like this. Now we can take our immutable subscription ID, stick it in here. Request confirmations. This is how many confirmations we want. This doesn't have to be chain dependent. It could be if you wanted to. I'm just going to go ahead and default this to 3 request confirmations no matter what. This is going to be a constant variable since we're not getting it through the constructor. And yeah, sure. GitHub Copilot, we'll call this state variables. So we'll do uint256 private constant request _ confirmations equals 3. So since this is a constant variable, we're going to do all uppercase here, right? This is more gas efficient. So we're going to do private constant request confirmations. We're going to scroll back down, boom, request confirmations, callback gas limit. This is going to be the max gas that we want the callback function to do. So on that second transaction, when we get the random number back, we're going to limit the amount of gas that it can spend, because if it spends too much gas, we're actually going to be the ones to front that cost. And if it's like a bajillion gas, I don't want to have to pay that. Different chains have different costs for gas. So this is something that I probably would want to put on my constructor here. So this is going to be a uint32. Again, all of this is in the Chainlink documentation if we ever want to refer back. Callback gas limit. We'll make this immutable as well. I_callback gas limit equals callback gas limit. Thanks GitHub Copilot for the auto tab here. And then up here, little copy paste. This is a uint32. So uint32 private immutable I_callback gas. Perfect. Now we can do I_callback gas limit. And then number of words is the number of random numbers that we want. We only want 1. We only care about getting 1 for 1 winner. So we can always make this a constant variable. So we'll do private constant num words equals 1. Grab the sum words, paste it down here. Okay, cool. Now our VRF coordinator, we're getting a little error here saying request random words was not found or visible after argument dependent lookup in address. What's going on here? VRF coordinator right now is of type address. So we can't call request random words on an address. This needs to be of type VRF coordinator interface. So what we can do is we can grab this from the Chainlink package, and we can even see this if we go back to the docs here, go to get a random number, we'll scroll down, and we can see they're actually importing from import at chainlink/contracts, src, v0a, interfaces, VRF, vcoordinator, v2 interface.sol. So we're going to do the same thing. Except for we're going to do a named import, of course. So we're going to paste that in here at chainlink/contracts, VRF coordinator, v2 interface. We're going to do a named import for that because we are awesome engineers. And then, of course, we're going to have to download this as well. We could download this from the smart contract kit /Chainlink repo, but we know there's the Chainlink Brownie contracts repo, which is a lot smaller and more minimal. So we're actually going to install from here. So we're going to pull up our terminal. We're going to do forge install smart contract kit /chainlink -brownie -contracts at 0.6.1 like this. Oh, and then we have to do, let's hit up twice -no -commit. And we're going to install this same as what we've done before. And since we have this installed, we go to our foundry.toml. We're going to do remappings equals, at chainlink/contracts equals lib/chainlink brownie contracts/contracts. Awesome. So now if we go here, all should be well and dandy. We're getting an error for our linter, but let's try running a forge build. Let's see if, saying lib chainlink brownie contracts src, saying this folder doesn't exist. So let's see, lib chainlink brownie contracts src v0.8 interfaces, VRF coordinator, v2 interface. That looks like it sure as heck does exist. Let's go back to our foundry.toml. Maybe I messed something up in here. I need this. I don't need the backslash there. Okay, cool. All right, now we're working fantastically. Okay, now instead of an address private VRF coordinator, we're going to make this type VRF v2 interface. And what we can do now down here is we can typecast this address as this interface. And now VRF coordinator is of type VRF coordinator v2 interface. And now if we scroll down, we don't get the error here anymore. Huzzah. We're getting two errors here. Invalid type for argument function call, invalid implicit conversion from type uint256 to uint16 requested. So it looks like request confirmations is of type uint16 instead of uint256. So we're just going to change that. And number of words is a uint32 and not a uint256. So let's go ahead and change that. And stuff's looking good. Let's just make sure this all works. Let's do a forge build. All right, awesome. So everything's working and we have an unused local variable, which is fine. We don't care about that. So cool. So now pretty much just with this, we have a way to actually make a request with the Chainlink contract. However, we also need to be able to get that random number back. So what we're going to do is we're going to need to actually import some code. So if we go back to the Chainlink docs, we scroll down all the way down here. We have request random words, which we've pretty much done. They give some other stuff we can do. We probably should omit an event as well, but they also have this fulfill random words. That's an internal override. And this is going to be the function that the Chainlink node is going to call in order for us to get our random number back. So we're actually going to implement that function so we can get our random number back. So we're going to call function fulfill random words. And it takes a uint256 request ID and a uint256 array memory random words. And all this is in the docs, of course. This is going to be an internal override like this. And this is the function the Chainlink node is going to call to give us the... So why is this internal override? We know what override does and we know what internal does. So if we're overriding this function, it means that this function should exist in our inheritance so that we can override it. And sure enough, if we look at the docs, we scroll up, they have us import this VRF consumer base v2. So we're actually going to go ahead and import that as well. We're going to use a named import though. So we're going to scroll back to the top, new line, paste that in here. And we're going to import this VRF v2 consumer base. And we're going to say our contract raffle is VRF v2 consumer base. And if we look in this contract, again, I'm going to command click. It might be control click depending on what OS you're using. When we scroll down, we can actually see there's this function raw fulfill random words. And this is an external function, but it has this check. If message.sender is not the VRF coordinator, revert. So this is the function that the VRF coordinator is actually calling. So when the Chainlink node gets a random number, it calls the VRF coordinator. The VRF coordinator will then call this VRF consumer base v2, which is going to be a part of our raffle contract. And then this function calls that fulfill random words function that we just created, which is up here, and it's internal virtual. So we need to override this, which is why we override this. Now, this VRF consumer base v2, if you just do is VRF consumer base v2 here, it's going to say no arguments past the base constructor. Specify the arguments or mark raffle as abstract. So whenever we do inheritance, and the inherited file that we use has a constructor. So in VRF consumer base v2, there's actually a constructor for that contract. We need to pass it that VRF coordinator. In order to use an inherited functions constructor, we need to pass that in our constructor ourselves. So here's our constructor. We'll paste the name of that contract in here, and then we'll pass whatever variables it needs in here. It needs the address of the VRF coordinator. So we'll just paste that in there and we'll go ahead and save and we'll see the red lines disappear. Hooray. So let's do a quick recap of that because I know we talked about a lot. So what's going to happen? We're going to make a request to the Chainlink node to give us a random number. It's going to generate the random number and it's going to call a very specific contract on chain called the VRF coordinator, where only the Chainlink node can respond to that. That contract is going to call raw fulfill random words, which is going to call fulfill random words, which we are going to define by overriding it. So we're going to define this fulfill random words. Basically, we're going to say, okay, now that we have the random number, what do we do? And for us, of course, we're going to pick the winner. Yay. So that's how we're going to get a random number. This is the input parameters for fulfill random words. The request ID is going to be the request ID that we got up here. And then actually, let's even just delete that. We're going to use this request ID in a minute, but the request ID is the request ID. And then it also passes this array of random words or random numbers. We're only going to be using the first one in here.